Okay, welcome to the video for going through the answer key. So what I'm actually going to do is just do the homework and talk while I'm doing it. And remember, this is in YouTube, not Edpuzzle, so you can just fast forward to whatever parts are of interest to you. So for 1 through 3, we are solving for theta, and we're not using a calculator. So the fact that we're not using a calculator and we're solving for theta indicates to us that we're probably looking at our special angles, which are 30, 60, and 45. So those are really going to be our only answer choices. And for each of these, we're going to give one answer in degrees and one answer in radians. So the first thing I want to do is kind of write out what I call my toolbox. So, the things that I'm going to use all the time when I'm dealing with 30, 60, and 45. So SOHCAHTOA, my 30, 60, 90 right triangle. Across from 30 is 1. Across from 60 is radical 3. And across from the hypotenuse is 2. And sometimes people swap the radical 3 and the 1, but remember which one's bigger, radical 3 or 1. Radical 3 is bigger than 1, right? So that means that the radical 3 has to be across from 60 because 60 is a larger angle. So since 1 is the shortest side here, it has to be across from the smallest angle. And then I have my 45, 45, 90. If you know the legs are 1, if you forget what the hypotenuse is, you can always just do Pythagorean theorem, because if you do 1 squared plus 1 squared equals hypotenuse squared, you'll get radical 2 anyway. And then other things you may want to make a note of, the fact that pi over 6 is 30, pi over 3 is 60, and pi over 4 is 45 degrees. Sometimes people also like to write down the reciprocals, like the fact that sine is reciprocals with cosecant. Notice that I don't write equals because they're not equal to each other. I've chosen an arrow to just kind of show that they have a relationship. So tangent and cotangent are reciprocals and so on. All right, so those are the things you might want to have on the top of your paper. When we go to solve for sine of theta equals 1/2 is the ratio and theta is the angle. So what we're going to do is we're just going to look for theta. It's either going to be 30, 60, or 45. I'm going to find it in degrees first and then just give my answer in radians also. So to find this answer, it's process of elimination. These are your 3 possibilities. So for sine, sine's opposite over hypotenuse. So check opposite over hypotenuse for each of these angles. If you start with 30, you'll see that sine is 1/2, so you actually have your answer right away. But if you didn't start with that, if you started with 60, you'd see it should be radical 3 over 2. That's not what we're given. And for 45, the sine would be 1 over radical 2. And 1 over radical 2 would end up being radical 2 over 2, so that radical throws things off. So 30 is my answer, and in degrees, that's pi over 6. So you can write your answer out like this, or you can write theta equals. You can put a comma in between, or you can put the equal sign in between. You can write the radians first. You can write the degrees first. Whatever way you want to present your answers there is fine. The next one's tangent theta equals radical 3. So we have basically 3 choices for theta, 30, 60, or 45. Now, since this involves a radical 3, I think it's safe to say it's either 30 or 60. 45, a radical 3 would never appear here. So we can probably cross that one out right away. For 30 degrees, tangent would be opposite over adjacent. So for 30 degrees, we would get 1 over radical 3. You don't have to write out that the tangent of 30 degrees is 1 over radical 3. But if it helps you to, figure out if you have the right answer or not, then it's okay to show work here. This would be radical 3 over 3. That does not match. So let's check 60. The tangent of 60, if tangent's opposite over adjacent from SOHCAHTOA, then for 60, that would be radical 3 over 1. And that comes out to radical 3. So 60 is what we're looking for. So our answers here are 60, and then just convert that to radians. In radians, that's pi over 3. Okay. For cosecant theta equals radical 2, well, that radical 2 makes me believe this is probably going to be 45 for our answer, but we want to go through the process and see which one is correct. So for cosecant, there's kind of 2 ways to do it. One way to do it is to actually use cosecant. If cosecant is radical 2, that would be radical 2 over 1, right? And the definition of cosecant, since cosecant is reciprocal with sine, is hypotenuse over opposite. So this is one way to do it. You can look for where hypotenuse over opposite is radical 2 over 1. So for 45, radical 2 over 1 would do it. So 45 is the correct answer. And if you want to check the other ones, check for 30. Hypotenuse over opposite for 30 would be 2 over 1. It's missing the radical. And hypotenuse over opposite for 60 would be 2 over radical 3. That's not a match. Okay, so 45 gets us our correct answer. Another way to do this, if you don't like working with cosecant, you can change this to sine. If cosecant is radical 2, then sine is 1 over radical 2 because they're reciprocals. So you can flip that ratio. Okay? And you could clean this up if you want or work with it as is. So since we're dealing with sine, this is opposite over hypotenuse. For 45 degrees, opposite over hypotenuse is 1 over radical 2. So we found what we wanted. The answer is 45. I don't know why I put degrees on that theta. Let me get rid of that. Okay. So the answer is 45 degrees, which is pi over 4 in radians. And again, it doesn't matter if you write the radians first or the degrees first. Just make sure for degrees you put degrees on there. Okay. And I think I'll continue. All right. So the next part involves using a calculator. So the way we know it's going to involve a calculator is because the directions say round to 2 decimal places. So if I'm rounding at all, we're using a calculator. And we're just going to do this in degrees. Like I mentioned in class, we could also do this in radians, but just to keep things a little simpler right now, we're going to do this in degrees. So taking a look, we have the ratio is given. I know this is the ratio because what happens with trig functions is the angle goes in, the ratio comes out. So we're trying to find the angle. We're given the ratio. In this scenario, we can find out what the angle is by doing sine inverse of the ratio. Okay, so for the inverse, we're going to put the ratio in and get the angle out. And that should make sense because for inverses, your outputs and inputs switch. So for regular trig function, angle goes in, ratio comes out. For the inverse, you're going to put the ratio in. It's going to give you the angle. Now for the mode, we're going to be in degrees because the directions say so. This ratio has no units. Okay, ratios don't have units. So this is not degrees, this is not radians. But theta, we want it in degrees, so I put my mode in degrees. Okay, so I'm in degree mode, and I can do sine inverse, that's second sine, 0.4676, and I get 27.89 degrees. I'm going to use the approximately symbol. Oh, I'm sorry, 0.8. What did I do? 27.88 degrees. Okay. And I'm going to use the approximately symbol here because I did round. Okay, so just if you're paying attention to the details, this is still equals, okay, because that was given and this is equals. But once I round, I have to use the approximately symbol. And again, I won't take off for that this year, but just if you're going to continue in mathematics, you want to pay attention to that detail. All right, next one. This is the ratio. We want to find the angle. So what we're going to do is tan inverse. And we're going to do tan inverse of the ratio. Okay, we're already in degree mode. So tan inverse of 4.1102. And I get 76.33. Don't forget to put degrees on there. Okay, so I'm not going to be crazy picky about the approximately symbol, but the degrees has to be on there. Otherwise, we'd think that you meant radians instead. You don't want to mean radians here. All right, and then for this one here, we can't do cotangent inverse because the calculator doesn't have that built in. If we could, we would. Okay, but this is not in the calculator. So what we need to do instead is we need to rewrite cotangent. Okay, so the way we do this is we rewrite, instead of cotangent, we put its reciprocal tangent. If we had cosecant, we'd write sine instead. If we had secant, we'd write cosine instead. Since this is cotangent, we're going to write tangent. And if cotangent is this ratio, then tangent is 1 over that same ratio. Now that you've rewritten this as tan theta equals, then theta is going to be tan inverse of that ratio. As I mentioned in class, sometimes people try to memorize how it's going to go in the calculator. I really strongly advise against that. What I would do is, let me go ahead and get rid of this part, okay? Because that was just to remind you that why we can't do cotangent inverse. Okay, so what I would really strongly advise that you do here is you write cotangent as tangent instead, and then think about what that means, what that relationship is. So if cotangent is 1.455, then tangent is 1 over that. Once you're here, you know how to free up tangent. You do tan inverse of this, okay? And that's my advice for you. And what we're going to get here is about 34.5, We're rounding to 2 decimal places, so you can have 34.5 degrees or 34.50 degrees. We're not doing sig figs or significant digits like you might in a science class. We're just doing rounding. So either one of these is fine with us.